Hi there. Can you hear me okay? Right on. Thanks for coming. I know you have a bunch of choices for sessions that you could have attended, and I'm guessing since you're in the room, you probably know a little something about OpenGL ES. What I'm going to do is I'm going to take you on a little journey to talk about Microsoft's involvement in OpenGL ES from an open source perspective, and tell you how to get started and fast track some of the ways that you can get your apps onto the Windows platform. We've heard a lot about that earlier yesterday and today in the keynotes about the iOS and Android. This kind of dovetails into those topics here. So it would be great if you could submit an evaluation at the end of this talk. It'd be great to know if these types of topics are on target for you. And any feedback to help me do this better would be great. Angle is a way to display OpenGL ES, and I can't think of a better way to do it than to show you a quick little demo. Okay. I don't know if the focus is there or not. All right. So what we're going to see here, this is a benchmark tool that the graphics team inside Windows that I'm a part of, we use this to kind of benchmark the performance of Angle, which runs on top of DirectX. So you're going to see a scene of this knight that he's going to go into a pyramid. You're going to see him go down. There's a little pool there. This projector is really doing it no justice right now. But you'll see reflections on the water. You'll see shadows and reflections off the tile. There's effects in the roof of the next room here. The thing to note is that in the top right corner, there's a vsync limited, which kind of denotes the performance of the of OpenGL ES on via Angle. So down here, you can see the haze in the top right corner. You know, I've got an even better way to do this, but this is a Lumia icon. So this is live. But how about I go one step better? Because it's not just for Windows Phone. This is a early build of Windows 10, and apparently I have to drag this over here. You can see the picture much better here. This is Windows 10 Pro running on a Surface Pro 3. So with an even better GPU, we've got much better performance going on here. And you can see, I mean, fortunately, the camera here is much clearer. You can see the clarity of the reflections and the shadows and the effects that are going on here. I should just let this go all the way through because the fight scene at the end is epic. It's only about 2 minutes. But while this is going on, I just want to gauge a little bit. How many people have worked with the OpenGL ES before? Just a show of hands. Right on. Okay, this is going to be great. I was expecting at a Microsoft conference that it might not have been as high. Oh, here comes the bad guys here. I'm going to let this die here. I don't want to ruin it. We can see it later. All right. So now that we've seen kind of what Angle is, I'm going to take you through a little journey about how it's set up. We're going to demo some of the Windows 10 features for it. We're going to hear about an actual case study of a Windows Phone application. You might have heard of it, Candycrush Saga. They've adopted Angle in their Windows Phone version, and it's live in the store now. We're also going to go over a couple of best practices when using Angle versus when just general OpenGL ES techniques. And then finally, how to get started and how to get more information about it. But first, let's talk about the background, about how the project started. There's going to be a couple of assumptions for this talk. Because you guys showed your hands earlier, so you're either an iOS or Android developer, or you've done OpenGL ES programming before, or those of you that haven't raised your hands, you're just curious, what is OpenGL ES? I've heard of it, and I know I should probably know something about it. The assumptions for the talk: OpenGL ES is used primarily in C++. And so a little bit of C++ background will help, as well as some of the, I'm not going to necessarily go over some of the terms in OpenGL ES, so that base foundation that most of you showed me, that's perfect. Doing graphics on Windows, there's much more options than what you see on the screen here. There's, I don't know, 7 or 8, but primarily for games, which is kind of the focus for our involvement with OpenGL ES, you're going to target primarily 4. And the commonality between all of these is that they all use C++. Win2D, which I don't know how many of you have heard that talk, but that one also uses a .NET interface. It's the only one on the screen that does support it. Direct3D is the end-all be-all for performance on Windows. It's used by the majority of the AAA titles that are shipping. Angle, which is the topic of this talk, we're going to go over much more detail about why this is an option for you. And Direct2D, if you're doing 2D text graphics, images, it's a highly performant API that's native to Windows that gets you the best way to render your 2D scenes. Angle stands for Almost Native Graphics Layer Engine. The best definition I found is directly from the Angle project page itself, so I'm just going to read it and emphasize a couple of words here. It's an open source project that allows Windows users to seamlessly run OpenGL ES 2.0 content by translating OpenGL ES 2.0 API calls to DirectX 11 API calls. There's a couple keywords in there. One is translating. It essentially takes the OpenGL calls, it has a OpenGL surface, takes the parameters like you would call into any other driver, and then converts it to DirectX friendly data formats and buffers, and then ultimately renders it through DirectX. The second one is it's focused primarily on ES 2.0. If you're looking for 3.0 or 3.1 support, the Angle project is close. Microsoft's involvement is primarily to help the 2.0 effort achieve stability. It started in 2010 by Google. It was originally an open source project. They're still managing the project today, but since 2010, there's now 15 companies that have up to 66 contributors donating time and resources to the project. The driving force for Angle initially was to get WebGL implemented for the Chrome browser on Windows desktop. Since then, some of the other companies that have been involved, such as Mozilla with their Firefox browser, Adobe with some of their presentation applications, Microsoft, obviously. We also have NVIDIA and Intel, who have some experience in doing graphics drivers. They've all helped with different motives, but it's created a nice foundation for doing OpenGL ES on the Windows platform. And by leveraging DirectX, you now have you have support across the Windows platform, because of DirectX, the native driver support there, it's rich. There's 20 years of experience of doing that. So that's the key to the universal aspect of the goal. Now, Microsoft wasn't involved in the beginning. We got into the game about 2 years ago. Our primary focus was to get support for Windows Phone 8.1 in place, as well as to get support for Windows Store. In order to get Windows Phone 8.1 in place, we had to lower the hardware requirements for running and using Angle. And the last one is to contribute code back to the project so that people who are using it have a satisfactory experience. You know, it's in our best interest because it runs on DirectX. We want it to represent DirectX in a positive manner, which it does. And you can see from the timeline down below, the aspiration here, and the reason why I'm here today is that we also have the universal Windows app support for OpenGL ES 2.0 via Angle. There we go. So what does it mean to support the Windows Store? Well, when we got involved, we wanted to make sure that we can support the Windows apps, obviously. So by supporting the Windows apps, we had to do a couple of things. We had to implement ways to use core window or swap chain panels as a rendering surface. And we needed to decrease the hardware requirements for Angle. So before Microsoft got involved, the minimum hardware requirement was feature level 10.0. And I'm hoping everyone's familiar with DirectX feature levels. If not, it's just a way to categorize the capabilities of your graphics hardware, given the device it's running on. So most Windows phones in market are running at feature level 9.3. And over the past year, we've added the support in the Angle project to get it to run on 9.3. By getting Windows phones, by getting Windows 8.1, Windows Phone 8.1, and now Windows 10, you now have the potential to reach up to 1.5 billion customers. We're talking about getting to 1 billion customers on Windows 10. We want that and the people who might lag a little bit behind, but we're making it available to everyone. And we want it available to everyone that's running Windows today, not just tomorrow. How's Angle set up? So we're going to walk through this kind of like I'm a developer that wants to make a GLES call. So the dark blue box, that's my call to the application. The first thing that you're going to run into is when you call your GL method, there's going to be a little bit of pre-validation. It's cheaper to do it at this point and to make sure that we have all the format, because the translation layer, which comes next, needs to make sure that everything's there in place. So we pre-qualify it. The benefit of that is that as a developer, this is where I can set my breakpoint and start my debugging process if I'm experiencing either perf issues or rendering issues with my code. The next layer is the translation layer. What the translation layer does is it takes the OpenGL ES GUI, and yes, that's an official word, and translates it to the DirectX terminology, right? GUI. So it creates the mapping for the APIs. So GL draw arrays gets mapped to its equivalent, or bind buffer. And then the key thing here, and this was where some of the work had to happen, is translating the GLSL, that's for ES, and translating that to HLSL for DirectX. It wasn't as easy as some would think. There's not a direct one-to-one correlation between the capabilities of HLSL and GLSL. Once we're done with the translation layer and the data is formatted, then we pass it on to DirectX, because the data is now prepared at this point, and then DirectX just renders it. And like I mentioned before, the DirectX ecosystem with its rich availability of graphics drivers, it runs virtually anywhere, as long as you're running Windows 8, 8.1, or 10. I mentioned open source. The open source aspect of this is that the Angle project has its repository. The motivations early on was that they wanted to get the Chrome browser to render WebGL in a desktop application. Our motivation was to be able to support the Windows store and any apps that go through there. So we had to create a branch that, and I really don't like using the word branch because it's not a true branch, if you will, because we take snapshots from the Angle project every 2 weeks. We do this so that we can stay in sync. You can see on the far right there that there's numerous contributors that contribute to the Angle project. We're just one of the many that do that. By being able to snapshot to that every 2 weeks, we get the benefit of the improved stability that's offered by the other contributors to the project. When we take the snapshot, we merge the code, and then we stabilize it, ensuring that you, being a Windows developer, when you take our code from our branch, it runs for Windows and Windows Phone. When we see things that we need to implement in the Angle project, we do like everyone else. We contribute back to the Angle project, and they have a pretty solid code review process where you submit your code and they do a +1, +2 code review process, and then once they accept it, it gets merged and all that stuff, and then it comes back down via snapshot. So we're always in sync with the latest and greatest. We might have things that are exclusive to the Windows platform, and those are noted in the gold boxes over there. The support for Windows apps through some of the Visual Studio templates that are available. We have extra features and functionality that is available through we'll show you how to use that through the samples that are downloadable. We also have solution files so that you can build the project without having to convert GYP to Visual Studio. Open source is one part of the fun. The other part of the fun is OpenGL ES Conformance. Fortunately, the Angle project manages most of that. We want to be a good contributor to the Angle project, and so we comply to the conformance practices of the Angle project as well. Angle achieved conformance on OpenGL ES 2.0, I want to say it was 3 years ago. Don't quote me on that. There's a note here about feature level 9.3. We talked about how Windows phones, most of them are 9.3. Conformance on 9.3 isn't official, only because there's 2 key features that are missing. One is the GL max varying. For those that are familiar with it, the specification requires 8. And because of the way that we translate and manage resources on a 9.3 device, we have to use one of those slots, so our max is 7. The other item that is not supported is GL front-facing. Hardware level 9.3 just doesn't support it. And so if you need that, you can drop down to software rendering. And I'll show you how to do that here in a little bit. We're not done yet. I'm just letting you know where you can get it here. So our project is hosted on GitHub. We have a repository via MS OpenTech, and on the site we have information on how to get started as well as the source code itself. So what I'm going to do is I'm going to show you. There we go. All right, so this is the landing page for our project. You'll notice that along the right, we have issues, pull requests, and wiki. The key information here is going to be in the wiki itself. If we scroll down to just below where the source is, this is where you can start to get the information about how to get your machine set up and your compiler building Angle. There's a couple of steps in there that need to get done beforehand, and as I go through the demo, I'll be honest, I had to go through and do those install steps myself before coming here. So the area of interest here is the wiki. On the wiki, you'll see different topics here around, how to navigate the repository, how to contribute. There's performance tips. There's sample code. There's a wealth of information. We're trying to actively work on this so that it's beneficial to you. So if you have feedback, please let us know. I'll let you know how to give feedback at the end here. All right. So let's get started with the first coding demo, because we like code, right? Should have been done earlier. Okay, here we go. So like I said, I've already set up my machine with the install instructions. So what I'm going to do is I'm going to create a new project here. The first thing you'll notice is that under the C++ Windows Universal, there's two new project types that are here. App for OpenGL ES, and then XAML app. These correspond to the core window and XAML swap chain panel implementations. And these are set up to make it easier to get started with an app. So I'm going to call this a very unique name. And we're going to put this not there. All right, so project starts up. So this is Visual Studio 2015 running on Windows 10. So if there's any glitches, it's not my fault. How about that? Just kidding. From here, I'm just going to compile it right away because there's enough infrastructure in place. We're going to be able to render something right away. So you see the basic constructs of a Windows app here. We'll run it. And what we should see is a spinning cube. This looks an awful lot like the DirectX one. It's not the same one. The interesting thing here to note for those that were talking about, or that were here for the last talk for Macs, the graphics debugger, there is some integration in place for the graphics debugger as well, primarily because it runs on top of DirectX. All right, that's real interesting to see that. So I'm sure for those of you that know OpenGL ES, you're probably like, okay, what did Microsoft do to make this run? Is there some sort of special Microsoft syntax that had to happen? Well, the answer is no. Aside from the app container that gets provided for you, you'll see right off the bat, and I'm hoping that's big enough for you guys. You'll see right off the bat, we've got helper functions for compiling your shader and your programs. But the interesting thing here is there's your first shader. There's no special syntax here whatsoever. We're using a string helper to create it. But other than that, I mean, it's GLSL. Likewise, for the fragment shader, I mean, that's even easier. There's nothing exclusive to the Windows platform here. Theoretically, you can take your code that's running on other platforms, your GL code, GL ES code, let me be specific, copy it into a project, and it'll compile. Some of the other interesting aspects of this file, you'll see we'll set up the vertex positions and the indexes, generate our buffers, and then we bind the buffers, and then the close down. The draw methods here, this is pretty vanilla boilerplate code here, where it's just more GL code, GLES code. No magic other than, okay, so the math helper, we're using the DirectX math helper. Here you can use DirectX. It offers the same thing as the GL math, but if that's your preference. And then draw elements. You don't have to know any DirectX to do this. The other file of interest, and this is where the conveniences are located, is in the app CPP. So here what we do is that we create the framework for you So you don't have to worry about your devices. You don't have to worry about your contexts. It's provided for you already in the templates. So we'll see, we'll jump right away to, and I'm sorry if anyone gets dizzy from my scrolling, I apologize. So we're going to go down to run. So this is the loop. This is, I don't know. This is the main program loop that does the rendering and the redraws every frame. And just underneath it is the initialize EGL, or EGL. I use EGL. These configs are what you would normally do in any other OpenGL ES app. The thing that I want to show you for sure here is we initialize 3 different sets of display attributes. The first one, we're going to make sure that we're going to test out that, hey, do you have DirectX 11 support for your device or machine? If not, then what we do is we drop down to the minimum requirement for Angle, which is feature level 9.3, hence the creative name on the method. And if we still don't have hardware support, then we're going to drop down to software rendering by using Warp. Now, of course, we want to try to prevent going to Warp for performance reasons. But we set them up, and then the next step here, we create, we do the tests. If it works, cool. If not, keep testing, keep testing. And then at the very end here, this is where we go to create our window using the core window that gets passed in the constructor. So you don't have to worry about any of this. It's already in the project template. If you want to play with it, or if you have better ways to do it yourself, this would be where you play with it. And then finally, the surface, context, and make current. So that's walking through how to get started with the project. It's a similar process for the XAML swap chain panel as well. What we're going to do now is I'd like to bring Johan and Michael up to the stage to talk about this process to the next level, which is our case study for Candycrush Saga. And just right over there.
Is this on? Oh, perfect. So hello everybody, my name is Johan, this is Michael. So we were part of the team that did the work on Candycrush for Windows Phone. So we're just going to give you some of our experiences of leveraging Angle actually during the development. So if you haven't heard about King is a company, oh, sorry. Wait. So King is a company is all about creating fun games. They have a lot of games, and using a fair amount of users as well, around like 356 million engaging customers, which is a great number. It's a highly diverse company with like 1,200 employees, situated in all over the world. Have the company offices in Europe, US, and Asia, and we are based in Stockholm in Sweden. Also, some technical facts that might be interesting, that they are using a lot of different engines to build these games. One of the engines that we have used then is their own engine. It's a custom engine. It's based on OpenGL with C++, about 300,000 lines of code. And it's a pure native engine actually used for mobile development.
So I'd like to tell you about the project, the Candycrush project. And it actually started out with making a version for Windows Phone 8.0. And that version was actually built with a tool that you all saw in the keynote, which was actually using the iOS code base. And that was all good. But since the engine is pure C++, and all the games are pure C++, and King has a strategy in doing native C++ development. And actually how the architecture for the games and the engine is like, we have everything written in C++, and we have thin bootstrappers. So on iOS, we have Objective-C bootstrappers that just kicks the game engine. And in our case, with Windows Phone, it would be great if we could use a C++ CX bootstrapper to kick the same engine. So that's what we wanted to do. So we actually rewrote this for the Windows Phone 8.1 release. So that is a totally native implementation. King has a strategy with native development, and it's extremely important that we use that the solution is portable. So we need to be able to run this on all different platforms. And we run it on the web, we run it on mobile, and we run it on Android, iOS, Kindle, and now on Windows. And we also need to branch out for all different kinds of media or social networks. So when the engine needs to make a Facebook call or whatever, we can branch out and we can use custom code for this specific platform to do that. When it comes to agility, when we move to the native implementation, we could really hook into the same CI continuous integration platform as the other platforms like iOS and Android. And that was really important because King uses a bi-weekly feature release schedule. So we can actually use the same infrastructure to release games for Windows Phone as we use with iOS and Android. And this makes it easier to do hot fixes and what have you. When it comes to performance, since some of the fixes are or performance tuning are in the engine, so if you fix it once, it would actually flow over to all the different platforms. We have optimized shaders, that's another thing, and we have a fairly flexible resource pipeline. So we can adapt that for different platforms. So in the Windows Phone case, we can actually use low DDSs for textures to get a better slice of the app, for instance. So that's about the Candycrush project. So if you download the 8.0 version today, you will get the Keynote tool version, and if you download the 8.1 version, you will get the completely C++ native version.
Cool. So the engine that we have been using and the games as well are highly abstracted and have a sophisticated architecture, which also means that the impact of leveraging Angle was actually not that big for us. For instance, we have used the XAML swap chain panel templates just as a starter to get this bootstrapping, the bootstrapping experience with C++. And then also, I guess some of you that have leveraged like OpenGL ES earlier have like abstracted all the GL calls in such a single file, which is the same case here in the engine, which meant that redirecting all the GL calls for Angle, which actually meant that we actually had to change like the header files in one single file. That was pretty much what had to be done to get Angle working and a very rapid implementation of Angle. So it didn't take very long time for us to actually get the rendering just working and everything blitted on screen actually. We did have some impacts on the shaders. We had to inject. We are using dynamic shaders. We had to inject like the precision float specification that you also saw in the demo that Tony showed. And then we actually used like DDS textures for a couple of the biggest textures. And the artists have decided that these can actually be compressed a bit. So we're using DXT compression and just using those specifically for the low-end devices, which are like, higher memory constrained. But it's running really nice with DDS textures as well. And when it comes to like, if we didn't have any issues or something, we did stumble upon a couple of issues because this project had been going on for a couple of months. But then again, we actually used like the GitHub wiki and the issues and communicated with the team through that official channels, submitting a couple of bugs that we had with scissoring, for instance. And it was very rapidly fixed, so now it's a very stable environment, very stable library that we are using. And And we have occasionally stumbled upon some performance optimization, performance issues that, like, the team has identified and said, oh, this might have been an angle issue, and we have used the tools that also Tony showed, like the graphics analysis and also the ordinary Windows Phone performance analysis tools, and actually always come upon that said that that actually is not an angle issue, it's usually a CPU bound issue or something. And those fixes have been applied and then have helped all the platforms and all the games that King is releasing. And that's a good, really strong benefit. So I didn't really know that, but have anyone used Angle in here? Tried it out? Because you really should. It's really easy to get going and get it implemented into your code. We are like amazed in how easy that was, and rapidly get just the rendering being done. And this has not been the issue for us, actually. So it's been a really cool trip, and you should really know that Angle delivers, and the team has been really solid in helping out, like through the official channels and such. So we really encourage you to try out Angle. Thanks.
Thank you, Johan and Michael. All right, so Angle delivers. There's a little bit of knowledge that needs to be in place before you can really start to maximize your production using Angle. There's a couple of things that can help your performance when specific to Angle. The first one being, we've implemented this feature called render to back buffer. And what it does is that it makes it so that you don't render to an intermediate before rendering to the final output. You can imagine having an intermediate step in there can take up some performance, especially in the marshaling between the surfaces, and it's just not, this speeds that up quite a bit. The other one of interest is that there's certain formats on the Windows platform in the conversion process, certain vertex buffer formats that aren't as efficient as others. And I would love to say that there's a simple formula. If you do this, then you should try this. It depends on how you implement your OpenGL ES code. If you think that you've done everything you can to get the most out of just your general GLES, this is definitely something to look at as a post-investigation, because by trying some of the formats. And we've documented a couple of them on the wiki. So if you're hitting this issue, come to the wiki and you'll see which ones are more problematic than others. And then in general, because you guys have done OpenGL ES before, this first one was interesting to me because we had a project that was trying to use Angle, and it was a project that didn't necessarily have high visual fidelity. And we just recommended, well, what if you dropped your resolution a little bit? You'd be surprised what a big difference this makes. They were hitting memory constraints, and they were able to run successfully on some of the 9.3 devices by just dropping the to a lower DPI. For those of you that use vertex buffer objects and you have static data, definitely make sure you mark it as static data. If you're not marking it, then the ambiguity makes it so it doesn't perform as well. If you don't know if you have static or dynamic data, this would be a great time to investigate this option as a performance enhancement. And this last one is interesting. So going to the Windows platform, let's say you're coming from iOS. There's a limited set of hardware that's available for iOS. Primarily the phones, then the tablets. So the device driver support for them is tightly controlled. Come to the Windows platform, we talked about having exposure to over 1 billion potential customers. Well, they're not running the same hardware. They're not even tightly controlled like it is on iOS. So there's going to be some differences in how some of the features translate over to Windows. The way that we try to manage it from a project perspective is to implement specific extensions on top of the base specification so that you can rely on it for the most part. These extensions also wound up becoming part of the base specification for the 3.0 implementation, even though 3.0 is not fully done yet. So just understand, why am I facing a couple of these performance issues? Well, the diversity of hardware that's available for Windows is just, it's great on most aspects, but sometimes if you're facing a performance issue, this could be part of it. I'm going to talk about a couple of key extensions that we recommend when using Angle. The first one addresses precompiled shaders. By enabling this extension, this is also one of those ones that's implemented in the 3.0 base. By precompiling your shaders and serializing the binary blob to disk, you save that compile hit every time you run your app. It'll compile it, serialize it, and then it's there. Next time you run your app, you don't have to take that hit. The texture compression DXT, what this allows you to do is to tap into the compression handlers that's available to you on the GPU. This, of course, is if the GPU supports it, but removing the processing time from the CPU. The next one, discard frame buffers. This is kind of a fast track shortcut. If you know you don't need to worry about your content in your buffer that you're rendering to, you don't need to keep it around anymore, tell Angle that it can just override it blindly and it won't try to protect it anyway. It'll treat it just like a new buffer. And then last but not least, instance arrays. Instancing, I don't think I need to talk about the benefits of instancing. We've implemented this extension in a way you just pass the points and you can reuse your objects that are already sitting on your GPU. If you were to take one thing away from this talk, and there's numerous things I hope you take away, but the one key thing is that Angle is an excellent way to get your OpenGL ES application running on the Windows platform. With the rich device driver support that fuels the DirectX backend, to the open source contributions that are provided from the community, to the enhanced features of the Windows platform with the Windows app and store and all that. It's tried, it's true, and it's a great stepping stone to get to the Windows platform with your ES graphics code without having to take the investment of going to DirectX directly. Now, one caveat is that this talk is focused primarily just on graphics. Obviously, when you're porting an application to the Windows platform, there's going to be other aspects to remember, such as input and audio and other portions. So we try to make it as easy as possible to take one of the more complicated parts of your app and make it work seamlessly on Windows. A call to action. So if you want to learn more about it, so we've got the wiki here, which is a pointer. There is a version of Angle for Windows 8.0. If you do have a hard requirement to support Windows 8.0 or Windows Phone 8.0, or sorry, Windows 8.0, you can see this repository. It's an older branch that has deviated from the current state, and so if you really need it, there it is. Link to the core Angle project itself, and we talked about feature levels. There's a definition there. To get started on Angle, I showed you the GitHub site, the homepage. There's a download link in the bottom corner. You can download the source as a zip, find the solution file for Angle, build it, and you're off and running. And then lastly, and this is one that I need to talk about for a second, So on the site, we saw the Issues tab. Issues aren't just issues, they're comments, they're questions, there's feedback, there's all sorts. We're just using the Issues section of GitHub in order to channel that communication. So don't think that, oh, I don't have a problem, I just have a question, I don't know where to go. That's where you go. So the Issues tab on GitHub there. And finally, like we talked about at the beginning, please evaluate the session. Let me know how I did. Let me know what I could do better. Let me know if this was on point for what you expected. And thank you very much. I'm going to be down in the Windows Insider Lounge for the next probably hour, but I'm open to questions right now if you have them. The mics are open and available.
Hi. We're currently targeting Windows Phone 8.0, and I think I looked into Angle a while ago, and I saw that there were projects for that. Have they been deprecated, or do you still have Windows Phone 8.0 support?
We do have Windows Phone 8.0 support. The second link is the one you're going to want to look at, because this is the version. Let me confirm that for you after this talk, and I'll make sure to get the information to you. I'm 95% sure Windows Phone 8.0 support is there. That's why I didn't want to make the claim earlier, but I'll confirm and I'll let you know.
Hello.
Hello.
Is there any good, do you know of any library for porting input and sound and everything, which works this simple between platforms?
So in the keynote yesterday and today, we talked about Islandwood and, for iOS, and for the Android being able to compile your Android apps in Visual Studio. Islandwood will allow you to port it. There's a little bit of work involved with the Android one. Like that, I will connect you with the right people. There's actually, so on the second floor by the window, there's a booth just for this. They're sitting side by side. One's iOS and one's Android. They would be the best ones to talk to about that.
The Marmalade team?
No, at the end of the, let's see the Windows Insider Lounge. Okay. Right next to the Windows Insider Lounge, there's two booths there that's on the back side on the glass. One's for iOS and one's for Android.
Okay.
Any other questions? All right, well, thank you very much for being here. I hope this was helpful, and enjoy Build.